So my name is Nyung. I'm currently CEO of a company called Horizon Legacy. I love two things. I love robots and I love construction. So I think I'm in the right place today. So we at Horizon are based out of Toronto, and we've been around since 1952. So after World War II. And since its founding, I'm the third generation. Since its founding, we've owned and operated around 7 million square feet of commercial and residential real estate, primarily based out of Toronto. So if any of you are familiar with Toronto, there's a CN Tower right over there, and then some of those red dots are buildings that we've owned and operated, sometimes for many decades. And we've done this model sort of from development from greenfield to construction to long-term ownership. Some of those are the buildings that we've owned and operated, and majority of them have been commercial banks, government institutions, et cetera. But what I'm here to talk to you about today is robotics in construction, and specifically the problem that we're focused on is the problem of retirement in the construction industry, with a lot of people, but 1 in 5 people are expected to be retiring in the next 10 years in Canada. So there's an organization called Bill Force Canada that has identified that there's around 100,000 workers that are in short supply because of two things. One is impending retirement of, sort of baby boomers or folks who have been working in the industry for a long time. And then the second effect is that young people are not really entering the construction industry at the same rates as they used to be before. And so it causes a problem for us because, when you don't have workers, then cost of construction goes up. And when you do have workers, the previous professor mentioned proper training. So when you don't have people that are properly trained, then the costs on a job site is very expensive. You get project delays, you have rework, you have all sorts of problems. And if there are limited construction workers who are qualified to do it, then when you go out to bid a job, the costs increase significantly. And so for big projects like what we've done in the past, it's very costly and expensive to do this. So in 2020, about 5 years ago, our CEO and chairman said, we need to look into robotics to build buildings. And specifically in Canada, we have a shortage of around 4.8 million units of housing as determined by the Canada Mortgage and Housing Corporation, which is an organization that manages housing for our country. So my colleague Pablo is here today. He's sitting over there, and he's going to be making a presentation at 11 o'clock. He's going to be talking about this project that we embarked in. It's the first and largest neighborhood in Canada using an on-site construction strategy with robotics, specifically 3D printing. We're about to finish the project. We built 26 rental units. The total cost, hard construction costs from foundation to roof was 300 Canadian thousand dollars per unit, which is a very good price. And it demonstrated to us that the technology, specifically 3D printing, can be deployed at close to cost parity with traditional construction. 30% of the units are deemed affordable rentals for social housing, basically below market price. We're planning the first block to be moved in by the end of October. We started construction on this project last year in about the same time, June, July. So it's quite a fast turnaround. And based on the building design, we chose an all-electric building, no natural gas, and our wall ratings are rated at around R30, which is above the industry or the normal building code standards. So we are projected to consume about 67% less greenhouse gas compared to traditional residential buildings of this nature. And one of the major achievements that our team was able to reach was that this building methodology reaches and satisfies all of the Ontario Building Code standards as required, went through the normal building permit process. So how we did that was through this robot. It's an industrial 6-degree axis robot. We named her Val. We added a 7th axis, and our team designed it so that we can pull this machine by a truck to the job site. This here is an example of a wall, one of the walls that we printed. This has gone through several iterations, so you can see now the quality has significantly improved. We're quite happy with that. But if you look at this wall on the left, and if you look at sort of the design here, that's essentially what it is. It's about 50-some segments deployed on the first floor. Our team started the printing process last year in October 1st, and we finished around the 3rd week of November for the 3D printing portion. So why is this relevant? I'm sure some of you know about 3D printing, but I want to give some context in terms of construction. What 3D printing is, the benefit of that technology is really that it eliminates formwork. And on a construction site, this is what formwork looks like, and this is how concrete is laid. So what you see here is, wooden forms placed by a large crew of people. Typically, it's a very onerous process. You're working in the trenches, you're working outside in hot summer days. And then you put rebar in there, and then concrete truck comes and pours concrete, and then you have to strip out those forms. It's a very labor-intensive process. And in Canada, which might be different than Europe or in other places, Asia, for instance, but certainly in Canada and certainly in Toronto, we build a lot of our buildings out of concrete. So if you compare that previous job site look to what a robot looks like on a job site, what you see here is, I think that's Pablo in the blue overalls there. And you have 3 people set up the machine, set up all the equipment, and it's programmed and it's running. And that's the setup. So you can see visually, there's a huge labor savings component to this process. And it also makes the process more attractive to young people who really are tech savvy and don't want to work doing manual labor jobs, being yelled at on job sites. They want to play with robots and computers. So that's what we've seen, and this is very exciting for us. This photo was taken a couple of weeks ago. This is the current state of the project, and these are some of on the right, some interior renderings of the building, what we want it to look like. Now we're finishing that project and we're starting a second project, and we're doing that is because we're very excited about what we learned in the first project. And so we're starting construction on the second project right now. It's going to be a multi-story, 3-story building, 30 units, probably the biggest footprint in the world at 21,000 square feet. So one of the biggest 3D printed buildings in the world. And what we're trying to demonstrate for this project is a curved form, a non-traditional rectilinear form. My purpose here today is to speak really briefly about the fact that we're very interested in collaboration as well and working with universities and people who are interested in this. We're creating a project pipeline where we will be inviting and experimenting with new robotics technologies in construction. So feel free to talk to me afterwards and we'll be happy to chat about that. Thank you very much.